Let's do a couple of examples of the product rule. And in the second case, being a little bit clever about why we're using the product rule at all. So recall that if I'm taking the derivative of a product, what I do is if I have two terms here, I'm going to make two terms here. In the first term, the first function has its derivative. In the second term, the second function has its derivative. So knowing that, if I have two functions here which are multiplied together, and I want to find the derivative at x equals 0, let's find the derivative at any general x, and then we'll plug in the specific value x equals 0. So what I need to do is I need to find this term's derivative. So by the power rule, the constant multiple rule, and the sum rule, what I get is 3x squared plus 5. And by the constant multiple rule, the power rule, and the subtraction rule, I get 15x squared minus 5. So those are my two derivatives. So the way that I want to get f prime here is, all right, so I'm going to have two terms each time in each grouping. The first term will have the first derivative, or the first term's derivative, and the second term will be normal. And then we're going to add the first term as normal and the second term's derivative. So that's our general rule. Now we could multiply this out if we wanted to. That wouldn't be a problem. And in fact, you might want to do that for your own edification. But what I'm going to do is, since we care about at the point x equals 0, I'm just going to plug in 0 here. And the reason that helps is because this whole thing is 0. So this term actually vanishes, no problem. Over here, the 3 vanishes, so we're left with a 5. Vanish, vanish, negative 3. And we're left with a negative 15. Now over here, we have to find this derivative. And we're going to learn techniques about how to find derivatives for fractions as we come up, but it's important to realize that we can also do this with the product rule. So what we can do is we can say that can be written as 3/4 x to the negative 7th. And technically we don't even have to do this with the product rule. We could do this with the constant multiple rule and the power rule. But just for simplicity's sake, actually let's do it both ways. Remember that by the power rule, we should be able to bring the power down and then subtract 1 from the power. So we expect to get that answer, which we could rewrite as that answer. But what happens if we do this with the product rule? So in this particular case, we set up this function and that function. Now this is a constant function, so its derivative is 0. And this is it follows kind of that polynomial rule. So you bring the power down to the front and subtract 1 from the power. So then when we're doing this, our derivative is we take the first derivative, second term, plus first term second derivative. And what you find is that this term vanishes, and that term becomes the one we found right there. So what we find is that the product rule is a very powerful tool, and if you think that you might have an issue with derivatives, sometimes it helps to set it up as the product of two derivatives, and then you can break down the problem into more manageable pieces.